All right, Wiley homework number 16. So it says the proton NMR spectrum of which of these compounds would consist of a triplet, a singlet, and a quartet only. Right. So they give us, what do they give us here? They give us 2 chloro 4 methyl pentane. So I'm just going to draw that. I'm sorry if these molecules are going to be a little small, but you'll be able to get the scans in the Facebook group. We have 3 chloro 2 methyl pentane, right? And that looks like this. Cl. We have 1 chloro 2 dimethyl pentane, right? And that gives us Cl. I'm just drawing in those molecules real quick. And then they gave us 3 chloro 3 methyl pentane. And that looks like this. Then we have 3 chloro pentane. Alright, so then I have all these molecules here, and from the information that they gave me, they want, right, a triplet, a singlet, and a quartet only. So that tells me that there's 3 signals. And that tells me that there's only 3 chemical shift equivalent environments. There's only 3 identical environments. So in order to get a triplet, I need to have something next to a CH2. In order to get a singlet, I need something that's not near any H. Okay, it's not near any H. In order to get a quartet, I need something that's near a CH3. So the first thing I did, there's 3 signals, so I went through these molecules and I looked for ones that they can only have 3 identical environments. So the first one, 2 chloro 4 methyl pentane, I looked at this and I said, okay, these 2 are identical. 1, there's a hydrogen here that's 2, 3, 4, 5. I think this has 5 environments. I think. So I said no, it can't be this because I only have one with 3. This one I looked there, so there's 1, 2, 3, 4, 5. I think this one has 6 environments, so I don't think that's, nope. 1 chloro 2 dimethyl pentane. This has, let's say, 1, 2, 3, 4, 5. That has 5 environments. It's not going to work. And then I have 3-chloro-2-methylpentane. This has 1 and 1. These are identical because they're symmetrical. 2. These are identical because they're symmetrical. And then 3. This methyl group up here, that's identical. So this has 3 environments. So that's okay because it has 3. So that's an option. And then I had 3-chloropentane. I have, these are identical, so that's 1. These are identical, that's 2. And then the hydrogen that's coming down here is 3. So that has 3. So it could be one of these two. So I'm looking at one of these ones. So now I need something that's CH2 connected to a CH3 and something that has no CHs anywhere near it. So the first thing I looked for the one that has no H's near it at all. I need to find something that's not anywhere. There's no H's within a 3 bond, right? This one, the singlet, I can't be near any H's within 3 bonds. So I looked and I said, okay, is there anything here? Is there any H here that's not near any H's within 3 bonds? No. Is there any H's here that are not near any other H's, any heterotopic H's within 3 bonds? Yes, right here. These CH3s, so you go from the H, there's the H to the C is 1, 2. This is a chlorine, there's no hydrogen here, so there's nothing within 3 bonds. So it's obviously this one. It can't be this one, but just to double check, so that would be my singlet. The CH2 would give the triple bonds, so these two CH3s are chemically equivalent, and they're both next to these CH2s, so they're giving the triplet bond. And then the quartet, these two CH2s are chemical shift equivalent. They're giving one signal. They're both next to CH3s, and they are giving the quartet. So the answer is 3-chloro. 3-chloro-3-methylpentane is the answer.